All right, guys. All right, guys, before we get started, we're going to go on and look at a question from the homework from last night. So, if we look at this problem here, problem number 15, so the x and x minus 2 are as simplified as they get. We can't simplify either one of those farther than what it is. Now, the x squared minus 3x has the greatest common factor of x. So when we factor the x out, we get x times x minus 3. Now, when we factor the other one, x squared plus x minus 6, the third term is negative, so the signs are opposite. Factors of x squared are x and x. 6, yes, we would use 3 and 2. 3 would be positive, 2 would be negative, and if we check this, negative 2x plus 3x does give us the positive x middle term that we wanted. So the first thing we would need to do is factor it to this point here. Now we multiply these together. We'd have x times x minus 3 times x minus 3 times x minus 2 on top, and x times x minus 2 on bottom. Now at this point here, the x minus 2 and x minus 2 would cancel. Our x and x would cancel, leaving us with x minus 3 times x minus 3. And that's it. We don't have to multiply it back out. We don't have to do anything else to it. This is the final answer. We can do one more. 17, 20. We can look at 20. X squared minus x minus 12 over x squared minus 16 is being multiplied with our x squared plus 2x minus 8. And even though it's not written that it's over 1, it's understood to be over 1. Now at this point here, we can factor these. The 1 is already simplified. And out of the 3 other polynomials that we need to factor, the x squared minus 16x is going to be the nicest one of the 3 because it is a difference of perfect squares. Because we would have x plus 4 and x minus 4. Now at this point here, we can start off with our x squared minus x minus 12. Since the third term is negative, our signs are going to be opposite. Plus and minus. Factors of x squared are x and x. And our factors of 12 are 1 and 12, 2 and 6, 3 and 4. So we can do 3 and 4. And if we do check this here, we'd have negative 4x plus 3x giving us our negative x as our middle term. Our last thing we need to factor out, x squared plus 2x minus 8. Since the third term is negative, our signs are opposite. Factors of x squared are x and x. Factors of 8 are 1 and 8 or 2 and 4. This time when we factor it, we would need x plus 4 and x minus 2. And we multiply this here, really we can just connect the two. And the x minus 4 and x minus 4 would cancel. X plus 4, x plus 4 would cancel, leaving us with x plus 3 times x minus 2. We can leave it in factored form. We do not have to multiply it back out. Questions on the homework? What we're doing today is dividing. We're dividing rational, dividing rational expressions. Okay. First step, we rewrite the first rational expression. So the first one's going to stay the same, 7 over 2x minus 10. We're going to flip it, or change it from division to multiplication, and flip the second one. Keep, change, flip. So the way we would divide two fractions, doing the same thing here, because rational expressions are just fractions. So when we're dividing two rational expressions, we keep the first one the same. We change it from division to multiplication and flip the second. Questions on this here? Now we're doing exactly what we just did yesterday. Because now we're just multiplying two. So now all we need to do is factor and then multiply. I'd start with the 2x minus 10. Because there's a greatest common factor of what? 2. And if we factor it out, we're left with x minus 5. Well, there's another one with the greatest common factor. And that's our x squared minus 6x. And the greatest common factor is x. So if we factor an x out of x squared minus 6, we get x times x minus 6. On top, the last thing we have to factor, x squared minus 11x plus 30. Since the 30 is positive, our signs are the same and match the sign of the middle term, so negative and negative. Factors of x squared, x and x. Factors of 30 are 1 and 30, 2 and 15, 3 and 10, 4, or not 4. I think I'm thinking of the next one. 5 and 6. 5 and 6. A good place to start. Because if these are indeed the correct factors, we will have an x minus 6 that matches up on top and bottom. We'll also have an x minus 5 that matches up. Now we can check and make sure. X times negative 6 is negative 6x. Negative 5 times x is negative 5x, giving us the negative 11x that we wanted. Now we can multiply these together. On top we'd have 7x times x minus 5 times x minus 6. On bottom, this 2 and this x are going to multiply together. Because they're outside the parentheses, they're our greatest common factors, they're going to multiply together, giving us, well, 2x. Times x minus 5 times x minus 6. What simplifies? Well, x minus 5 and x minus 5. X minus 6, x minus 6. And our x's here will simplify out, leaving us with what? Number 2. And it can't simplify, that's it. would be the one to look at. So for the most part, is this any different than multiplication? Not really, just barely. Our first main step's the only difference. Questions on this here? Keep, change, flip. We're going to keep the first rational expression the same. We're going to change it from division to multiplication and then flip the second. Keep, change, flip. Now the nice thing out of all this here, 11x is just 11x. It's a single term. We can't do anything with it factoring wise. I would go for greatest common factors first. 3x minus 9 does have a greatest common factor of 3, which will factor to 3 times x minus 3. Any other greatest common factors? X squared minus 5x has a greatest common factor of x. Since they both have x in common, we can factor it out. X out of x squared leaves us with x. X out of 5x leaves us with 5. X squared minus 8x plus 15. We don't have any term in common with all three. So we'll have our two sets of parentheses with 3 spaces. Now, if something's going to simplify, one of those parentheses has to be either what or what? X minus 5 or x minus 3, yes? If we get one of those, then we need to have something that simplifies. And we will indeed get both. Since the third term's positive, signs are the same, match the sign of the middle term, so minus and minus. Have x and x, and one of the factors of 15 is 3 and 5, so it's a good place to start. X times negative 5 would be negative 5x. Negative 3 times x is negative 3x. Again, it is good to just verify and make sure that that is the middle term that we want. Because it could be that that's not the middle, that x minus 3 and x minus 5 aren't the factors and nothing simplifies. But here, those are the correct factors and this will simplify. On top, we have 11x times x minus 3 times x minus 5. On bottom, we have what? 3x times x minus 3 times x minus 5. Well, simplify out what's in common, and it leaves us with 11/3. Questions on this here? These are kind of nice, and especially when it works out this way is interesting. I think the only time it gets more frustrating is when we get these big factorizations on top and bottom. We go through the whole process of factoring everything, and it all reduces to 1. Like, why is it all that work just to get 1? But questions on what we've done so far? We feel good with this here. I'm going to skip this one, not so much because it's not important, but I actually want to see, since y'all are feeling comfortable with these, having another one that works out to just be, I think it is, yeah, 4/5. Let's actually look at one that doesn't just simplify to a number, where we actually have some expressions left over. So again, our first main step is to keep. Change. Flip. Keep, change, flip. And we get this here. Did you mean to write? Look back at that line. I don't know if you meant to write that. Okay. A minus 2 and 2a minus 1 are not going to factor. Now, there's two main ways we know that. One, a and 2 do not have a greatest common factor. There's nothing in common with a and 2. On bottom, 2a minus 1, there's nothing in common with 2a and 1 besides 1. So greatest common factor doesn't simplify. A minus 2 is the degree of it is 1. So there's no way we can do sets of parentheses and factor. Same thing with 2a minus 1. They're as simplified as they get. Well, let's start off with a squared minus 4. A squared, so we do have a degree of 2. Two terms being subtracted. What times itself is a squared? A and a. What times itself is 4? 2 and 2. So this is a difference of perfect squares. I'll grade it with the other half in a minute. Now the top, 4a squared minus 1. If it's going to factor, it's going to be a difference of perfect squares, yes? So what times itself is 4a squared? 2a and 2a. And then 1 is 1 and 1. Difference of perfect squares, I think, becomes more of the one, or one of the ones that's nicer to factor, because we find out what times itself is each of the terms, throw them in plus minus. Questions on how we got to this point? Now, we are going to multiply these together, yes? Really, what are we doing? We'll put it as one big one. So we could rewrite it if we want, or we can just connect the two and simplify. 2a minus 1, 2a minus 1. A minus 2, a minus 2. So we're left with 2a plus 1 over a plus 2. That's it. Questions on any of this here? Questions on this here? Get ready for the next one. Y squared minus 9 over y squared divided by y to the 5th plus 3 to y to the 4th over y plus 2. Keep, change, flip. Y squared and y plus 2. Simplified as they get. Simplified as they get. We can't do anything with them. Which one do y'all want to factor next? Y squared minus 9 would factor 2. Y plus 3. Y minus 3. Last one we need to factor is y to the 5th plus 3, y to the 4th. There's a greatest common factor of y to the 4th. Because since both of them do have y in common, we take as many y's out as the degree of the smallest one. Because the first one we have 5, the second one we have 4. So the most we can take out of both is 4. Because once I take 4 of the y's away from y to the 4th, it doesn't have any more. I can't take any more away from it. Which leaves us with this here. Now we can merge these together. We will have to be careful with the bottom, the y squared and y to the 4th, because we can't just put them next to each other. We can, but we can't. What's in common? Y plus 3 and y plus 3. So the top is going to be y minus 3 times y plus 2. On bottom, we have y squared and y to the 4th. When we multiply those two together, we get y to the 6th. And again, we can leave it in this factored form. We don't have to multiply it back out. We don't have to rewrite the numerator as y squared minus y minus 6. We don't have to put it back as defactored, multiply back out. Leave it in parentheses. No reason to multiply it out. Yes. Actually, let's do this one here first. So we'll do this one here. There's one piece to it. Now, the cubed part will come a little bit into play, but not too much. A cubed plus 4a over a squared minus 16 is being multiplied by our a squared plus a minus 20. Keep, change, flip. A cubed plus 4a has the greatest common factor of what? A. And if we factor the a out of a cubed plus 4a, we get a times a squared plus 4. Which one do we want to factor next? A squared minus 16, which would be a plus 4 and a minus 4. Now I'm going to go on and put the sets of parentheses on the other one because neither the top nor the bottom has the greatest common factor. So we'll do our sets of parentheses. Which one do y'all want to do first? Top one, a squared plus a minus 20. Since the third term is negative, our signs are opposite. Factors of a squared are a and a. Factors of 20. 1 and 20. 2 and 10. 4 and 5. 4 and 5. Does it matter which one's positive, which one's negative?
Probably
5 is positive, 4 is negative. Since we don't have a number in front of a, it's not going to impact it. But we know the middle term's positive, so probably the bigger number should be positive. And we can check and make sure. A times negative 4 is negative 4a. 5 times a is plus 5a, giving us a positive 1a, which is exactly what we wanted. A squared plus 8a minus, or 8a plus 15. Third term's positive, so signs are the same. Match sign in middle term. A squared is a and a. Yes, factors of 15, 1 and 15, 3 and 5. 3 and 5. And if we check it, a times 5 is 5a. 3 times a is positive 3a, giving us the positive a to a we wanted. We can multiply them together. Now let's simplify what's in common. a minus 4, a minus 4, a plus 5, a times a squared plus 4, a plus 4 times a minus a plus 3. Now, the a squared plus 4 on top, we do have two terms. There's nothing in common, but the degree is 2. Since the degree is 2, there is a chance it can factor. And with two terms, a is being squared. So a is a perfect square, yes? 4 is a perfect square, yes? Is it a difference of perfect squares? It is a, what's the sign in the middle? It's a sum, because we have a sum. We're adding two things together. We do not have a sum of two squares. Sum of two squares doesn't factor. Sum of two cubes factors, but not a sum of two squares. This is as far as it goes. Or at least it doesn't have real factors. We only want real factors. And that's it. Questions on this here? So, how do we feel about these here? For the most part, this division is not so much the division itself as what gets harder. It's just how we factor, what we factor. Two left. We're going to do this one and one more. Now, just like yesterday, even though the denominator is not written, it's understood to be 1. Now, for multiplication, it didn't make a big impact because it just stayed a denominator of 1 the whole way through. Here, our first step is to keep the first one the same, change it from division to multiplication, and flip. Keep, change, flip. So when we flip, keep, change, flip. So now the one's on top. All right, guys, focus in. So besides that, this is the exact same. One of the numerators is going to be 1. Now we need to factor here. The 3x squared plus 5x is going to be a little nicer to factor because the greatest common factor is x. And if we factor it out, we're left with 3x plus 5. Now, if we look at 6x squared plus x minus 15, is there a greatest common factor between these three terms? No. And if something's going to simplify, one of those two sets of parentheses has to be what? 3x plus 5. It's the only thing we have on bottom that can simplify. Now, the third term is negative, so our signs are indeed opposite. Factors of 6x squared, well, we will have x and x. 1 and 6, or 2 and 3. 2 and 3, and the 3 would be with the plus, 2 would be with the minus, because if we're wanting to match it up with the 3x plus 5, we need the 3x with the plus. Let's see the factors of 15. 1 and 15, 3 and 5. We'll put the 5 with the 3x so that we do have matching terms. Now we can check this and make sure. 3x times negative 3 would be negative 9x. 5 times 2x is plus 10x, giving us the positive 1x that we want. All right, guys. What's in common? 3x plus 5 and 3x plus 5, which leaves us with 2x minus 3 on top. Because we do actually have 2x minus 3 times 1, which would just be 2x minus 3. On bottom, we have 4x squared times x. So our final answer is 2x minus 3 over 4x cubed. I will let y'all pick one of the last two. Which one you want to do? Yeah. We're not going to do the... Oh, Everett. If you want a warm one, in that closet. I just haven't pulled them out yet. Yep, thank you. It should be right there. All right, guys, last one we're doing here. Keep, change, flip. 6x is going to stay the same. 1 is going to stay the same. They're simplified. Greatest common factor between 2x squared and 5x is, well, x. All right, guys, focus in. Focus in. 2x squared plus 3x minus 5. Since the third term is negative, our signs are opposite. Now, our factors of 2x squared, we'd have x and x. Now, if it's going to match up to something on bottom, we need the 2 with the 2x with the plus. Factors of 5 are 5 and 1. Because if something's going to simplify, I need one of those sets of parentheses on top to be 2x plus 5. And we can check it here. 2x times negative 1 is negative 2x. 5 times x is plus 5x, giving us the positive 3x that we want. And if we multiply these here, 2x plus 5, we'll cancel out with the 2x plus 5. Squared. Because our x that we had from factoring out on the other one. Questions on this here? That's it.